Okay, for question number 32, part B, using integration, we have to find the area bounded by the ellipse and the lines x is equal to -2 and x is equal to 2 and the x-axis. But this equation is not in the standard form, and we know that the standard equation of the ellipse is x square by a square upon plus y square by b square is equal to 1. So let's get this converted into the standard form, and we are going to divide all this with 225, each and every term with 225. So this is 9 by 225 x square plus 25 upon 225 by y square is equal to 225. Okay, so this is now 25, this is 9, and this divided by 225 is 1. So this is x square upon 5 square plus 1 square upon y square upon 9, which is 3 square is equal to 1. And this is the length of the semi-major axis, that is a 5 units. So R and B. So if we compare this with the equation x square upon a square plus y square upon b square is equal to 1, if we compare these equation, which gives me a square is equal to 5 square, which is a is equal to plus minus 5, which is a semi-major axis, and similarly y is equal to plus minus 3. So that means semi-major axis and the major axis. So it goes like our ellipse goes like this. Okay. So this is 5 units. Semi-major axis is 5 units, and the semi-minor axis is 3 units. Now, there are two lines, x is equal to -2 and x is equal to 2. So x is equal to -2 is here, and x is equal to -2 is here, and x is equal to 2 is here. Okay. Now we have to find the area, and our area is this one. This is the area between the x-axis. So it's between the x-axis. So that means okay, so our area of concern is between the x-axis, x is equal to -2 ellipse, and so this is the area that we have to find. This is the shaded area between x is equal to -2, x is equal to 2, x-axis, and the ellipse. So let's find out this area. So the required area is equal to, it goes from the limits -2 to 2 y into dx. Okay, and y, we can get the value of y from here. So this was our equation. So it gives me y square is equal to 1 minus x square by 25 and multiplied by 3 square is 9. So y is equal to 9 by 25 is out is 25 minus x square, which gives me y is equal to 3 by 5. This is now 25 minus x square. So y into dx means this goes from the limits -2 to 2, and this is 3 by 5. So 3 by 5 is out, and it's y into dx. So let's put in the value of y, or we can write it as, because these two regions are symmetrical. So I can write it as 2 times 3 by 5, 2 times the region that goes from the limit 0 to 2. So I'm going to find the area of this region. This region is symmetrical to this region. So find the area of this region and multiply it with 2, because this gives the limits 0 to 2. So now it's 2 times the area of this region, but with the limit 0 to 2 into y into dx. So this is now 6 by 5 and y is 25 minus x squared. So 2 into 3 by 5, and here let's put in the value which was under root 25 minus x squared. Okay, so this is 6 by 5, now 0 to 2, and now this is of the form a square minus x square. And we know that the integration of under root a square minus x square is x by 2 under root a square minus x square plus a square by 2 sine inverse x by a. So let's use this identity here, which gives me 6 by 5 is out into. So this is x by 2. So this is x by 2 under root a square minus x square, which is 25 minus x square plus a square by 2. A square is 25. So 25 by 2. And this is sine inverse of x. And a is 5. This is 0 to 2. So let's evaluate this for the limit 0 to 2. And I'm going to write it here. This is 6 by 5. Let's put in 2. So this is 2 by 2 under root of 25 minus 2 square is 4 plus 25 by 2 sine inverse x, which is 2 by 5. Okay. Minus. And now let's use the limit 0, which is 0 by 2 is 0, so this is 0, and sine inverse 0, so obviously this should be 0. Okay, so finally we are left with this is 6 by 5. 25 minus 4 is under root 21 plus 25 by 2 sine inverse 2 by 5. This should be the required area. So uh, so this is x by 2 under root a square minus x square. So 2 square is 4, 25 minus 4 is under root 21. So 6 by 5 under root plus 25 by 2 sine inverse 2 by 5. Okay, let's multiply it with it's 25 minus 4. Okay, so this is finally I can write it as 6 under root 21 by 5 plus if we multiply this with this is 6 by 5 into 25 by 2, 5 by the 25 and 3, this is 15. So 15 sine inverse 2 by 5. So 6 under root 21 by 5 plus 15 sine inverse 2 by 5 square units is the required area.